This is a walkthrough of Problem 3 on Exam 1 of Module 2 in the book Problem Solving Guide for Mechanics and Thermodynamics. An arrow is shot 80 meters above a canyon floor at an angle of 36.87 degrees above the horizontal. On the other edge of the cannon, a second archer waits with a crossbow. He shoots a bolt horizontally 2 seconds after the arrow is shot at a speed of 120 meters per second. The arrow and the bolt strike the floor of the canyon at the same place at the same time. What was the initial speed of the arrow? How wide is the canyon? We need a good diagram for this one, and the problem came with one. So here's the arrow. It's shot up at 36.87 degrees above the horizontal. We don't have the initial speed of the arrow, though. The bolt is shot 2 seconds after the arrow is released. The bolt is shot horizontally at a speed of 120 meters per second. Arrow and the bolt hit the canyon floor at the same time. At the same place at the same time. What was the initial speed of the arrow? How wide is the canyon? The initial speed of the arrow was neither in the x or the y direction, but we don't have initial speed. Okay. Well, let's work with the bolt, I guess. See what happens. It's a hard problem, so just start doing stuff and maybe the light will come on. You don't have to see all the way to the end before you start. Just start doing something after you understand the problem. So, the bolt in the initial speed of the bolt in the y direction is, do not get this wrong. The problem's already hard. Let's not make it any harder. It's 0. The bolt is shot horizontally. The bolt travels 80 meters downward with an initial speed of 0. The acceleration is 10 meters per second every second. There's our equation. If we're doing the y direction, the initial speed is 0. That makes it easier. So we put the 2 on the other side. We get 80 divided by 5, that's 16. Square root of 16 is 4. And let's check that answer. You drop something from rest. After 4 seconds, it's going to be going 40 meters per second. The average speed from 0 to 40 is 20 meters per second. If it averages 20 meters per second for 4 seconds, it goes 80 meters. And that's the height of the canyon. So it's all consistent. So the bolt hits the canyon 4 seconds after it was shot. Now we're making some progress. The bolt was shot 2 seconds after the arrow was shot. They hit the floor at the same time. The bolt was shot 2 seconds after the arrow. The arrow must have been in the air for 6 seconds. Now we're getting somewhere. The arrow was in the air for 6 seconds and it fell a net of 80 meters. We can calculate the initial speed of the arrow in the vertical direction with that information. This is for the arrow, 1f(at) squared, and we're going to put v initial y. We don't know what v initial is, but we're going to solve for v initial y. So the arrow fell 80 meters, minus 80 meters, the acceleration 10 meters per second squared down. It was in the air for 6 seconds. We have one unknown, the v initial y. Half times 6 times 36 is 180. Put the 180 on the other side. We get 16.7 meters per second for the initial speed of the arrow in the y direction, and we have the angle. Now we can get its initial speed. Sine of 37 degrees is opposite over hypotenuse. The hypotenuse is the initial speed. The opposite side is 16.67. That's the vertical component of the speed right there. Initial speed must have been 27.8 at 36.87 degrees. Part B is how wide is the canyon. For this, we need the horizontal distance traveled by the arrow and the bolt, and then we can add them up. The bolt goes 120 meters per second, and it's in the air for 4 seconds. Horizontal speed is always 120 meters per second. And that's what we're caring about, the horizontal speed. That's 480 meters. So we need the horizontal speed of the arrow. We can use Pythagorean theorem. V squared equals Vx squared plus Vy squared. We know what V is and we know what Vy is. We can get Vx. 22.2. If it goes 22.2 meters per second for 6 seconds, travels a distance of 133 meters. So, the arrow and the bolt hit the floor of the canyon at the same time, the same point. So we have 480 meters for the bolt, 133 meters horizontally for the arrow. That's 613 meters. This diagram is not to scale. That's 80. This is 613. That's okay. For extra credit, just kidding, calculate the distance between the bolt and the arrow when the bolt is released, and the speed of both the bolt and the arrow when they hit the floor. Are they going the same speed? Is one going faster? Figure it out.